Good day, guys. Darian Giuseppe here, back again with another video for the Key Concept series. Today, what we're going to look at is plotting a point on the Argand diagram. We're going to look at finding the length of a complex number and also to finding the argument of a complex number. So first things first, let's look at this big heading here, the Argand diagram. And what is the Argand diagram? It's a diagram that shows the plot of a complex number. It's similar to the Cartesian plane, but it's a bit different in the sense that where we have a x and y axis in the Cartesian plane, we now replace the x-axis for the real plane when we look at the Argand diagram, and we replace the y-axis for the imaginary plane when we look at the Argand diagram. So let's consider a general complex number of the form z is equal to a plus bi. So if we were to just plot this, where a and b are positive real numbers, so they would be in the first quadrant. This is what we will have, something like this here. Key things to note when we're doing our sketch, let's just make sure and label the axes correctly. So what we traditionally call the x-axis, we will now label that REZ as the real axis. What we traditionally call the imaginary axis, the y-axis, we will label that the imaginary axis, IMZ. So those are some key things to note when you're doing your plot of your Argand diagram for a specific complex number. You want to make sure and label your axes correctly. Also, make sure and plot your point correctly, where A is your real part, B is your imaginary part. So make sure and plot them correctly. And also you want to join the plot to the origin. Yeah, your origin would be here. And make sure and drop a little arrow there, because in the Argand diagram, the complex number is represented as a vector. So those will be the things that you want to make sure you note where the Argand diagram is concerned and plotting a complex number on the Argand diagram. So that's that. Next thing we want to look at is the modulus of a complex number, modulus or length of a complex number, and what is the formula there. Also, with quick other thing, we want to make sure, we want to note here from the Argand diagram, you may notice this here, this little R here, and the theta. You don't necessarily have to draw in those, but the R and theta relate to the length and the argument of the complex number. So what we need to do is look at how to find R, which is the length, and how to find theta, which is the argument. So let's get straight into that here now. So these are things that we want to note. The modulus or length of the complex number is given by, and it's given by the square root of the real part squared plus the imaginary part squared. So this is the formula here. R, or the modulus of E plus BI, is given by this formula here. And that is key for you all to learn, because this will come up in the exam. Also, we want to look at the argument of a complex number. The argument of a complex number is simply the tan inverse of the imaginary on the real part. So it is the argument of the complex number is given by this here. Theta is equal to the arg of E plus BI, which is given by this formula here. And this is very important, very key. Your imaginary part B on your real part. So that is key there. Some other key things where the argument is concerned are, whenever you're calculating the argument, you need to remember to keep your calculator in radians. So the argument, these are things to note about the argument, is measured in radians. So keep your calculator in radians. A next thing about the argument is that it is measured from the positive real axis. So it's always measured from this here to wherever the line that the complex number joins the origin with. So that is key. As well, also, the principal argument of Z is such that it ranges, this is the range, negative pi is less than theta, which is less than or equal to pi. And that is very key as well to note. And lastly, when finding the argument, you need to note where the complex number lies. Depending on where the complex number lies, that would tell you whether or not the answer that the calculator or that your calculator gives you is the answer for the argument for that particular complex number. What you need to note is that if the complex number, when you plot it in, or when you just draw a little quick sketch, because that's what you could do, if it lies in the first or the fourth quadrant, you could just do a quick sketch to see where it lies. And if it lies in the first or the fourth quadrant, then the answer that the calculator gives you is the answer that you would use as the argument. So this is the first point here. This is very key. So if it lies in the first or fourth, theta, or the argument, is given by the calculator. It is tan inverse of the imaginary on the real part. If, however, it is found in the second quadrant, what you need to do is take the answer that the calculator gives you and plus it to pi. So that is the next thing you want to note. If the angle, or if, sorry, the complex number lies in this quadrant, so when you do your sketch, it lies in the second quadrant, you need to make sure and remember to add pi, and that would be your correct argument for that complex number, right? And lastly, if the complex number lies in the third quadrant, what we need to do is minus pi to tan inverse of the imaginary on the real part. And that would give us our answer for the argument for that complex number. So that is the last thing to do there. So this is what you would do there if it lies in the third quadrant, minus pi. So, right, you want to make sure and note these key things about the argument of the complex number when calculating it. Make sure your angle is in radians. It's measured from your positive real axis. The principal argument, you need to make sure that the angle that you get, it is within this range. If it is not, you would need to either add pi or minus pi, depending on what it is. And well, we discussed as well the length of the complex number, how we find the argument of the complex number. Those two formulas are very important, and also to sketching sketching a complex number on the Argand diagram. Very key as well, because all these things could be asked in the exam. Guys, so with that said, feel free to like and subscribe the channel, and if you feel as though this video would help anybody, right, doing exams, feel free to share it, and see you in the next video.